According to National Electrical Code Section 430.101b, the disconnecting means for a motor must open all ungrounded conductors. The switch must disconnect both the phase and neutral conductors, if present. The disconnecting means must be within sight of the motor. This means the switch must be visible from the motor so that maintenance personnel can easily de-energize it. Furthermore, the disconnecting means must be capable of being locked in the open position. This prevents accidental energization of the motor. Now let's consider the provided switch, a single-pole double-throw center-off switch. This type of switch has one phase conductor passing through it and two output terminals. When the switch is in the up position, the phase conductor is connected to one output terminal and the motor runs in one direction. When the switch is in the down position, the phase conductor is connected to the other output terminal and the motor runs in the opposite direction. The switch returns to the center off position when released, disconnecting the motor. However, this provided switch does not meet the requirements for a disconnecting means because it does not open all ungrounded conductors. In both the up and down positions, the phase conductor is still connected to the motor, posing an electrical hazard. Therefore, the switch could be considered a controller. A controller is a device that regulates the speed, torque, or direction of a motor. According to National Electrical Code Section 430.102, controllers must be installed in a locked enclosure and have a disconnecting means. In conclusion, the provided switch is not acceptable as the disconnecting means required by National Electrical Code Section 430.101. If it is used as a controller, an additional disconnecting means must be installed to disconnect both the motor and the controller. To reiterate the key points, let's delve deeper into the requirements for a motor disconnecting means as outlined in Article 430 of the National Electrical Code, commonly referred to as the NEC. Firstly, the NEC mandates that the disconnecting means must open all ungrounded conductors to the motor. This is a fundamental safety requirement. It ensures that all sources of power to the motor are completely cut off during maintenance or repair work. A single-pole double-throw switch, even with a center-off position, typically only interrupts one conductor. In many electrical systems, there are multiple ungrounded conductors supplying power, especially in three-phase systems. Therefore, a single-pole switch is insufficient as a disconnecting means. Secondly, if a neutral conductor is present as part of the motor circuit, the disconnecting means must also disconnect this neutral conductor. This requirement aims to prevent any potential for current to flow through the motor even when the phase conductors are disconnected. Thirdly, the disconnecting means must be within sight of the motor. The NEC defines within sight from as being visible and not more than 50 feet distant. This proximity is crucial for safety. It allows the person performing maintenance to visually verify that the disconnecting means is indeed in the open or off position before commencing work. It also allows for quick access to energize the motor in case of an emergency. Fourthly, the disconnecting means must be capable of being locked in the open position. This lockable feature is a critical safety measure. It prevents accidental or inadvertent re-energization of the motor while someone is working on it. The NEC specifies that the disconnecting means must have a provision for being locked in the open position, regardless of whether a lock is actually installed. Now let's consider the application of the single-pole double-throw switch. A single-pole double-throw switch is designed to control the direction of the motor's rotation. In the up position, the motor rotates in one direction. In the down position, it rotates in the opposite direction. The center-off position stops the motor. However, this functionality is characteristic of a motor controller, not a disconnecting means. A motor controller is a device used to start, stop, regulate, control, or protect a motor. While it can start and stop the motor, it does not necessarily provide a complete isolation from the power source as required by a disconnecting means. If the single-pole double-throw switch is used as a motor controller, then an additional disconnecting means that meets the requirements of NEC 430.101 must be installed. This additional disconnecting means must be readily accessible and located in sight of the motor and be capable of being locked in the open position. It is important to note that the size and type of disconnecting means must be appropriate for the motor's horsepower rating and voltage. The NEC provides specific guidelines for selecting the correct disconnecting means based on the motor's characteristics. Let's also address the concept of a controller versus a disconnecting means in more detail. The controller's primary function is to govern the motor's operation. This includes starting, stopping, speed control, and protection against overloads or faults. The disconnecting means, on the other hand, serves one crucial purpose: to completely isolate the motor from the electrical supply for safety during maintenance or repair. A controller might incorporate overload protection, such as thermal overloads, but it does not provide the complete isolation offered by a disconnecting means. The NEC requires that all motor circuits have both a controller and a disconnecting means. The controller manages the motor's operation, while the disconnecting means ensures safety during servicing. The requirements for motor disconnecting means are in place to minimize the risk of electrical shock or arc flash incidents during maintenance. By completely isolating the motor from the power source and providing a lockable disconnecting means, electricians and other qualified personnel can work safely on the motor and its associated equipment. Furthermore, the within sight from requirement ensures that the disconnecting means is readily accessible in case of an emergency. This allows for a quick and safe shutdown of the motor if necessary. In summary, a single-pole double-throw center-off switch is typically not acceptable as the sole disconnecting means for a motor, as it does not meet the requirements of NEC 430.101. It is more likely to be considered a motor controller, which necessitates a separate, code-compliant disconnecting means. Always consult the latest edition of the National Electrical Code and local electrical codes for specific requirements and interpretations in your jurisdiction. When selecting a disconnecting means, ensure that it is properly rated for the motor's voltage and horsepower, and that it meets all applicable safety standards. Remember that electrical safety is paramount, and proper adherence to the NEC is essential to prevent electrical hazards. If you are unsure about the correct application of a single-pole double-throw switch or any other electrical component, consult with a qualified electrician or electrical engineer. Now let's talk about some other common misconceptions. Firstly, some people believe that if a motor is small and low voltage, a simple switch is sufficient as a disconnecting means. However, the NEC requirements apply regardless of the motor size or voltage. All motors must have a disconnecting means that meets the code requirement. Secondly, some may think that if the motor is rarely used, a disconnecting means is not necessary. Again, the NEC requirements apply to all motors, regardless of their frequency of use. Thirdly, some people mistakenly believe that a circuit breaker can serve as both the overcurrent protection device and the disconnecting means. While a circuit breaker can provide overcurrent protection, it may not always meet the requirements for a disconnecting means. A separate disconnecting means may still be required. Fourthly, some might think that if the motor is hardwired and not connected to a plug, a disconnecting means is not required. The NEC requires a disconnecting means for all motors, regardless of how they are connected to the power source. Now let's discuss some additional considerations regarding the location of the disconnecting means. The disconnecting means should be readily accessible. This means that it should not be obstructed or difficult to reach. The disconnecting means should be located in a safe and convenient location, away from potential hazards such as water or flammable materials. The disconnecting means should be clearly labeled to indicate its purpose. This will help to prevent confusion and ensure that the correct disconnecting means is used. In addition to the above, it's essential to consider the environmental conditions in which the disconnecting means will be installed. If the environment is corrosive or contains excessive moisture, a disconnecting means that is specifically designed for those conditions should be selected. This will help to prevent premature failure of the disconnecting means and ensure its continued reliability. Also, it's crucial to ensure that the disconnecting means is properly installed and maintained. This includes regular inspection to check for signs of damage or wear, and prompt replacement of any defective components. Proper installation and maintenance are essential for ensuring the continued safe and reliable operation of the disconnecting means. Now, let's further expand on the concept of ungrounded conductors. In electrical systems, ungrounded conductors are those that carry current from the source to the load, in this case, the motor. These conductors are typically identified by colors such as black, red, and blue in a three-phase system. The NEC requires that the disconnecting means open all of these ungrounded conductors to completely isolate the motor from the power source. A single pole switch, by its very design, can only interrupt one conductor. Therefore, it cannot meet this fundamental requirement for a motor disconnecting means. Furthermore, it's important to distinguish between a single pole switch and a multi-pole switch. A multi-pole switch is designed to interrupt multiple conductors simultaneously. For example, a two-pole switch can interrupt two conductors, and a three-pole switch can interrupt three conductors. If the motor circuit involves multiple ungrounded conductors, a multi-pole switch would be required to meet the NEC requirements for a disconnecting means. In addition to the number of poles, the ampacity rating of the disconnecting means is also a critical factor. The ampacity rating refers to the amount of current that the disconnecting means can safely carry continuously. The disconnecting means must have an ampacity rating that is equal to or greater than the motor's full load current rating. This ensures that the disconnecting means can safely handle the normal operating current of the motor without overheating or failing. The NEC provides specific guidelines for determining the appropriate ampacity rating of the disconnecting means based on the motor's horsepower, voltage, and other characteristics. Let's also delve deeper into the lockable feature of the disconnecting means. The NEC requires that the disconnecting means be capable of being locked in the open position. This is a critical safety measure that prevents accidental or inadvertent re-energization of the motor while someone is working on it. The lockable feature typically involves a provision for attaching a padlock or other locking device to the disconnecting means. This locking device prevents the switch from being moved to the closed position, thus ensuring that the motor remains de-energized. The NEC does not specify the type of locking device that must be used, but it does require that the locking device be substantial and capable of withstanding reasonable force. The locking device should also be readily identifiable, such as a brightly colored padlock. The use of a lockable disconnecting means is an essential element of a lockout/tagout program. A lockout/tagout program is a safety procedure that is used to prevent accidental energization of equipment during maintenance or repair. The program involves placing a lock and tag on the disconnecting means to indicate that the equipment is being worked on and should not be energized. Lockout/tagout programs are widely used in industrial settings and are often required by OSHA regulations. In addition to the above, it's important to consider the type of enclosure that is used to house the disconnecting means. The enclosure should be appropriate for the environmental conditions in which it will be installed. For example, if the environment is wet or corrosive, a watertight or corrosion-resistant enclosure should be used. The enclosure should also be sized appropriately to accommodate the disconnecting means and any associated wiring. The NEC provides specific guidelines for selecting the appropriate type of enclosure based on the environmental conditions. Finally, let's re-emphasize the importance of consulting with a qualified electrician or electrical engineer when selecting and installing a motor disconnecting means. Electrical work can be dangerous, and it's essential to have the knowledge and expertise to do it safely. A qualified electrician or electrical engineer can help you to select the appropriate disconnecting means for your specific application, ensure that it is properly installed, and provide guidance on safe operating practices. In summary, while a single-pole double-throw center-off switch might seem like a convenient way to control the direction of a motor's rotation, it typically does not meet the stringent requirements for a motor disconnecting means as outlined in the National Electrical Code. A separate code-compliant disconnecting means is usually required to ensure the safety of personnel working on or near the motor. Always prioritize safety and consult with qualified professionals when dealing with electrical systems.